Okay, we're working with a linear function that only has a number, which basically gives you a horizontal graph. We already did step 1 and step 2. Now we're going to work on step 3. Okay. Step 3 will be finding the intercepts. Step 3, intercepts. Okay. Now remember that for the intercepts we always have two types of intercepts: the x-intercept, okay, and the other one, which is the y-intercept. Yep. So what we're gonna do to find each one of the intercepts is that we're gonna copy the formula, but instead of fx we're gonna put letter y. Okay, we do that to find the intercepts. Okay, y equals -3. That's what we're gonna write. Okay, so we're gonna put that thing here. Okay, y equals -3. Now to find the x-intercept, that basically what I have to do is the other letter I have to change it or substitute it with 0. So instead of y I'm gonna put 0. Okay, so I will get 0 equals 3, and I should find letter x in here, but because there's no letter x, technically it's kind of like if I cannot find it, right? Not only that, once I substitute the letter y with 0, I get basically something that is impossible. Okay, like 0 equals 3, that cannot happen in the system of numbers that we're working with. So those things are not equal. So that kind of like gives me the hint that there's actually no solution for this thing. Okay, if there's no solution for this thing, I could put that the ix doesn't exist. You could put like this, doesn't exist, or you could put that there's none. Okay, there is no x-intercept. Okay, I'm gonna leave it like this, like the x-intercept doesn't exist because there is no x-intercept. Okay, and the y-intercept, for the y-intercept we will do the same thing. Okay, well, I'm gonna copy the same formula of the exercise, and I'm gonna change the other letter, which is letter x, with 0, but because there is no x in here, I don't need to change anything. And once I do that, I'm gonna have to find y. I already found it because the formula itself, it already tells me that y is -3 in this case, not +3, so it will be -3, sorry. Okay, -3, yep. So because I already know that the y-intercept is the y that I try to find is -3, then I'm going to put let me put this thing here. I'm going to put the y-intercept will be then remember that the 0 is on the x and the -3 is on the y. Okay, so y-intercept will be 0, -3, and that will be basically the steps for the intercepts. We usually tend to verify whether we have the right intercepts on the graph, like to check whether we are doing things right or not. There is no x-intercept because the drawing, it never crosses the x-axis, like the numbers that we have in here. The drawing is never crossing them. Okay, so that kind of like shows you that actually there is no x-intercept. X-intercept doesn't exist because the drawing is never crossing through this line. Now the y-intercept is related to the y-axis, the vertical line. Okay, and if you see, the drawing is crossing exactly on 0, -3. So that's kind of like the y-intercept, the point where the drawing is going to cross on the y-axis. If you see that the drawing actually crosses in there, then you know you're doing kind of like things okay. Once we do this, we're going to have to check the domain and the range. That will be step number 4. So for working on step number 4, we're gonna have to check the domain and the range. So we should kind of like start discussing what is the domain. We usually just write R, but in this case let's try to understand a little bit about the domain and the range. So the domain is basically, horizontally speaking, where do you have the drawing? From where to where is this line drawn, horizontally speaking? You cannot say like from -5 to 5 because the arrows on the line basically tells you like they go forever. So it will be basically from -infinity to +infinity that this line exists. Horizontally speaking, this line exists in each one of the numbers, okay? Because in -4, yes, there is a point in here which is -4 comma -3. On -3 there's a point that is -3 comma -3. Like in each one of the numbers, horizontally speaking, you have a part of the drawing. The drawing exists in all of the numbers. That's when we use letter R to say that the drawing is basically in all of the numbers. Okay, so the step 4, which is the domain and also the range, is basically gonna tell me that the domain is R because the line exists horizontally in all of the numbers. Okay, now what about vertically? Let's focus on the Y's. Okay, check vertically, where do we have the drawing? Do we have drawing on 1? Vertically speaking, is there any drawing on 1? No, right? There is no drawing at 2 either. There is no drawing at 3. Where do we have the drawing? The drawing is only on -3. That's the only place where you can see drawing. Okay, like if you say me like, no, there's drawing on 4, that's horizontally speaking. But vertically speaking, you only have a line in here. There is no other place, vertically speaking, where you have drawing. Like there is no drawing in here. Okay, like there is no drawing up, there is no drawing down. There is only a drawing on -3. That's the only place where you have drawing. That will be the range. So the range, or the place, the vertical place where the drawing is just -3. The range is just gonna be -3. When you're only gonna copy a number and not like the entire, like all of the numbers, when you just want to put a number, you're gonna have to use curly brackets. Okay, so in this case the range will be number -3. Okay, the range will be -3. Now, what about the type of drawing that we have in here? Because it's a line and it's not a vertical line. Okay, remember that only vertical lines are not functions. The rest of the lines, either inclined, that are increasing or decreasing, or like this one that is horizontal, all of those lines are linear functions. Like what we have in here is a linear function. Okay, so that will be the type of the exercise. Step 5, the type will be linear function. Okay, we have a horizontal line, but that is still a linear function. Only vertical lines are not functions. Those are vertical lines. Okay, and if we're trying to analyze the growth intervals, which will be step number 6, we will have to check whether this thing is increasing, decreasing, or if it's constant. Okay, if it were increasing, then the line will be going up. But if you check, like if we put the imaginary friend like to walk on the line from left to right, it will move on the same place. Okay, it wouldn't go up, so it's not increasing, and it wouldn't go down, it's not gonna fall, so it's not decreasing. It stays on the same number. It doesn't move from -3. It stays always there. So basically this is a constant interval that we're having here, right? The entire line is constant. So If we talk about increasing intervals, we don't have increasing intervals. That's why the increasing interval is going to be empty. If we talk about decreasing intervals, there are no decreasing intervals. That's why the decreasing interval is also empty, because it's not going up, it's not going down, it stays horizontal. That's what we're going to call a constant interval. So the constant interval is going to be R, because it's constant in all of the numbers. That's how we're going to discuss, like, basically how the behavior of this line is. Okay, it's constant. It's not increasing, neither decreasing. So once we do that, we basically have done all of the steps of this thing. We kind of like analyzed this linear function completely. And that would be it.